Hello everyone, if you followed along in the last video, now what you have is an integrated 3D character into your scene. But we need to go through the process of actually spawning that character into the scene now, and automating the process for creating our render texture. So let's go ahead and do that now, and let's open up the 3D character script. Okay, so in our character script, let's think about what we need to do. Now we are no longer just spawning one object. Our base function here is going ahead and taking care of the spawning of the character prefab, but inside of this inheriting constructor, we need to take care of spawning the render group, but we need to know what that's called. It is similar to our character prefab. If we look in the character folder, it's just called render group instead of character. So let's just quickly define a constant to represent that value. And we'll use the curly brackets 0 inside of the square brackets. That way we can use the formatting function of the string to just insert the character name. And for our 3D model character, we're going to want to keep track of the render group that's been spawned in for this character, which would include its camera and its actual model. So we'll represent the root of this with a private game object, and we're just going to call this the render group. So once we create our character, let's go ahead and create that object in the scene. First of all, we need to grab the actual prefab from the resources folder. So render group prefab is going to equal resources.load, and we need to load the type of a game object at this particular path. This is going to be from our root assets folder, and we need to go inside of that folder and find something else, which will be string.format, and we're going to be formatting the character render group prefab name format with the name of our character. But just in case we're using casting data, let's not use the name, because the name could be like red guard or guard 2 or something. Instead, let's go into the config of our character and grab the name from that, because that's going to be constant for whatever character it is that we've spawned in. Such as if we make a character called guard, it's still using the generic type, so the actual name on its config will be generic, and generic will match the actual name that's associated with the render group prefab. It'll be render group generic instead of render group red guard, because we don't know those names. So we've got that. We've got our prefab now, and now let's go ahead and spawn it in the scene. So let's say render group equals object.instantiate render group prefab. But we need to parent it to something. We need to parent it to our character panel. So we can grab this from our character manager dot panel, and we need to grab the panel model 3D. But one thing that we need to change, if we hover over that, it's expecting a rect transform, which technically qualifies as a transform, but we're not going to have that in the scene. We've just got a regular transform because the 3D characters in this instance are not part of the same canvas. They all have their own canvas. So they're not attached to a rect transform, they're just attached to a regular transform. So let's go back into the actual character manager and just make sure that we change this from rect transform to transform. This is going to spawn our render group with the camera and the model into the scene. And we'll already have the character spawned onto the actual, or the raw image that renders the character onto the main canvas. So what we need to do is make sure that we set, or we grab any other components that we need and apply a copy of the original render texture to this particular character, just in case we make duplicates of them. Let's first of all, before we try to grab any components, we need the object to be active, that way it can find whatever components we want, such as our camera and our animator. So let's make sure that our render group dot set active, let's make sure that it's active in the scene. And then we need a couple other items. So we're going to want a reference to our camera. So let's make a private camera. And then we're going to want to reference to both the model container and the actual 3D model. The model container is used for the rotation, so that way we can control the direction of the character, while the model is controlled for animations and even other finer movements and rotations and what have you. So the private transform for the model container and the model. And then we're going to want the animator that's on the actual character object. So private animator, and we will call this model animator. And the last thing that we want is a blend shape, or the blend shape controller, so that way we can change the facial expressions for our character. So private, and this is going to be inside of a skinned mesh renderer, and we'll call this the model expression controller. The last thing that we might want reference to, or we're definitely going to want a reference to, is the actual renderer that has been spawned onto the character panel. This would be what's part of the character prefab, that image that's receiving the render texture. Through this renderer, we can control the colors and the fading and the overall visibility and motion of the character on the UI. So let's make a private raw image called the renderer. And with that, we're ready to continue. So we've got our render group spawned and it's active. Now let's go ahead and grab the camera. So camera equals our render group dot get component in children camera. And then we want the model container. And the model container is just the only child of the camera. So model container equals camera dot transform dot or get child, and we'll just get the first and only child. And then the model animator equals model container dot get component in children animator. So we've got the animator, and then our model is going to be the same object that holds our animator. So we can say model. Actually, to do that a little better, what I may say, I also know that model is the only child of the model container. So model equals model container dot get child 0. And then model animator equals model dot get component animator. And that means the next thing we want to do is grab our expression controller so that we can control those blend shapes. So model expression controller equals model dot get component in children, and we can say this will be a skinned mesh renderer. Now, if we hop into Unity, we're getting an error here from our character class saying that it can't convert a transform to a rect transform. So let's go ahead and take care of that real quick. And that's because we changed our model 3D panel from a rect transform to just a regular transform. So what we can simply do is change the parent panel from a rect transform type to a transform type. That way it can take any of what we have. Doesn't matter if it's rect transform or a transform, it'll still take it as the panel to which the character is parented to. But we don't even need to do that really, because this character panel is not going to be used for the actual character objects. It's used for the render group objects. And that might be something that you have to get in your head as to what the difference is. The character prefab, obviously, that's on the main canvas that controls the motions, and the root animations, that has nothing to do with the actual model. It's just the rendering. The render group has everything that's responsible for rendering the model of the character onto the render texture. So we're not actually going to be spawning our character prefab, which is what this constructor will take care of, on this panel, because this panel expects the model, while what we're actually spawning is the UI version of the character. So we can simplify this, and maybe we could even do the same thing for Live 2D where they have their own render groups, but I'm going to leave them the way they are because that just works. And we'll just go ahead and add another case in here. Actually, no, we won't. In this case, I'm just going to get rid of this whole switch statement. And I'm going to say parent panel equals, let's do a quick check. If config dot character type equals live 2D, then we're going to return the character manager dot live 2D panel. Otherwise, we're going to return the character manager dot character panel, because technically models should have their character prefab spawned onto the regular sprite and sprite sheet panel as well, because they're using the same logic there. They're just receiving the texture from the render group. Okay, so that's that. Now there's one quick thing that we need to take a look at with our character. So if we come into the character object, we notice that all of these parts of this character have skinned mesh renderers on them. So when we're trying to find the one with the blend shape, it's going to look through these and find the first one that has the skinned mesh renderer. But as we can see, that would be bottom body, which does not have the blend shapes here at all. As a matter of fact, none of these have blend shapes except for the face, because that's the only part of the model within Blender where the blend shapes were applied. So instead of trying to find the skinned mesh renderer as just whichever one of the children has it, let's find whichever one of the children has it, but also has blend shapes applied to it. That way we're guaranteed to get the right one every time. Okay, so let's go ahead and say get components in children. So we're getting all of the ones that have the skinned mesh renders on them. And then let's do a first or default. So we're going to grab whichever one matches what we're looking for. So we'll just check whatever we're searching as SM for skinned mesh, and then check if the skinned mesh dot shared mesh dot blend shape count is greater than 0. So if the skinned mesh render that we're looking at as part of the children has blend shapes, then that is the one that we'll use for our expression controller. And that takes care of that render group. So now let's go ahead and take care of our render texture and make sure that it renders to the actual character prefab in the UI. So let's make sure that we get our renderer, and that's going to be our animator, which is part of the base character dot get component in children, and we're going to be looking for the raw image. I know my 3D characters only have one raw image that represents the whole character, so that's all I'm going to look for here. And now let's go ahead and get our render texture. So we know that we have one saved inside of the character folder, and it's just called render texture. Let me go ahead and come up here and just define the default name for the render texture. So public constant string character render texture name format equals render texture. There we go. Okay, so render texture, and this will be the render text. This will be resources. We'll load it from resources dot load. We're going to load it as a render texture, and we're going to load it from the root assets folder. Inside of the root assets folder, we're going to, let me make sure I'm doing that right. We're going to look for that that render texture name. So character render texture name format, but yeah, no, we don't need to do a format there. So that's good. That's going to grab our render texture. So now we have the default, and now we just need to clone it. So let's say render texture new text equals new render texture, and we're going to clone the render text that we got above. After we've done this, we now have a clone of our render texture, so it's unique for each character instance that we create. And now we can go ahead and apply it to our renderer. So renderer dot texture equals new text. But we also need to do the same thing for our camera. That way it's projecting what it picks up into the new texture that's been created. So camera dot target texture equals new text. Okay, if all of that is right, we should be able to go into our scene and spawn the character in and have it just work. So inside of test characters, I'm just going ahead and creating Amaria on the screen, and then I'm going to move her to the right side of the screen. Let's go ahead and disable these objects in the scene, that way there's nothing there, and come into our managers, to our character manager, and make sure that we've applied our character panel to the character's model 3D game object here inside of the model 3D render group. Next thing we need to do is we need to add this character to the configuration of our character configuration asset. So let me add a new entry, and this one's going to be Amaria AM, and I'll set the type to model 3D, and that should allow us to spawn her in the scene. So let's give that a try. Nothing happens because I need to enable my testing object. Let's give that another go. Okay, there we go. So she moved, and because I didn't yield first, it was an instant transition because of the Unity game startup delay. But if we come down to her body, we can see that texture is now, it looks empty, and it's no longer selectable to lead to anything in the project. And that is good. That means it created its brand new render texture, so it's completely separate from the other one that we had made previously. So that's good. Our character looks to be working. Something I might want to do is I might want to rename the render group. That way we don't have Amaria clone right there. So let me go ahead and do that down here. I'll say render group dot name equals string dot format. This will be the character render group prefab name, and we're just going to inject the name of the character in there. There, and as we run that again, we can see that we have character Amaria and render group Amaria. So they're both spawning as they should be with no issues going on there. And what's nice about that is if we actually enable Raylene, Stella, female student 1, with our 3D character being rendered in this way, we could actually change the order here, and she will automatically render behind our sprite characters. So rendering your 3D characters like this is good for a lot of different ways in the visual novel. It's good for sorting, it's good for colors and fading, revealing, and different effects like that, and without having to go through some fancy other ways. But like I said, very important to remember that with the size of the render textures, you don't want to have a crazy number of characters on the scene at any time. As long as you stay below like 20, you should be good. In the animator, I'm just going to go ahead and make a transition from wave to idle. That way once she waves at us, she'll automatically go back to idle. And then inside of our Model 3D character script, let's go ahead and make a public void called set motion, just like we did for Live 2D, and have a string for the motion name. And we'll say our animator, no, not our animator, because that's for the base character, our model animator dot play, and we're going to play that motion name. So in test characters, after I create our character, I'm going to say Amaria.set motion, and I'm going to tell her to wave at us. Running this in Unity, she moves over, and now she's waving at us. So our character animation is working. Let's get another variant of her. So we'll do Amaria 2, say Amaria 2 as Amaria, and then have Amaria 2 dot move to position vector 2, I cannot spell, vector 2 dot 0, and then have Amaria wave, and then yield return new wait 4 seconds. Let's wait for 1 second, and then say Amaria 2 dot set motion wave. Now we've got two Amarias, but you can see we've got some weird thing going on there. We got double characters showing up, and that's not good. But if we go into our scene view, we can see why. Our first character, if we come to the render group, is being rendered here, but also our second character is. So hop back into the game, we can see that the render textures, or rather the cameras, are capturing both characters through the same texture, and that's because they're spawned within the same place. So we need to offset these 3D characters, that way each character is specifically within their own rendering space. And we can do that by basically stacking them on top of each other. So that way by changing where they are in the actual 3D world space, we can control just one character being per texture. So if we find a nice value that fits for each character. Let's see, starting there, it's a 0 offset, we move down, so about 15 might be good. Let's try that. In our Model 3D character script, let's make another constant. Let's make a public constant int, and this will be the character stacking depth. And I'm just going to set that to, yeah, 15. Character stacking depth. So then we can take our render group. So render group. And we need to set the transform dot position to equal, let's say vector3 dot down multiplied by some sort of value. So we want to figure out how many characters are on the screen, but not just any characters, only the Model 3D characters, because those are the only ones that we need to worry about stacking on top of each other. But we don't exactly know that yet. So let's come into our character manager and make a way to figure out how many of each type of character is on the scene at any time. So let's make a public integer return function called get character count from character type. And then character type as the parameter. So let's go for each var character in, actually character is the name of the class, so for each var c in characters dot values from our dictionary. So we get all the list of characters, and then we're going to look through each one. If c dot config dot character type equals the character type specified, then we need to increment a value. So let's make that value count, and if we find a character, then count plus plus. At the very end of that, we'll just go ahead and return our count, which means we can grab the total number of 3D characters by saying int models in scene equals character manager character manager dot get count from character type, and we want to look for model 3D. So we want to look for that character type. So then we will multiply our stacking depth times the models in the scene. But make sure that we are plus equals, so we're assigning it. Okay, so we should start stacking them for each model that we get. There we go. And yep, we can see that that is working. They're both playing their own individual animations through their own renderer. And if we look in the scene, yep, they are indeed starting to stack on each other. So perfect. That's great. We've got our model 3D. God, I'm going to mix these names up so many times until we get out of the character section of this tutorial, which is very soon. So, yeah, we've got our model 3D characters showing up in the screen, and that's pretty much it for this part. So in the next video, we will work on getting expressions to work for our characters so we can change their blend shapes and use those along with animations. I'll see you guys in that one. Bye. Oh yeah, don't forget to take off the additional audio listeners that are on the cameras for these render groups. So let's go ahead and do that right now. Let me go ahead and remove the audio listener from there, and then take our render group, override apply all, and hide that object again. Let's launch Unity and make sure that error does not persist, which it does not. Now we only have that one audio listener. So we're good. Now we're done.